Figure 2 represents a closed circuit. Use it to answer the questions. Use it to answer the following questions. So this is the figure. So we have the figure where we have resistor R1, we have resistor R2, we have R3 and R4. This is figure 2. We have the supply here. So the question says, determine the total resistance in the circuit given that R1 is 10 ohms, R2 is 60 ohms, R3 is 50 ohms, and R4 is 40 ohms. And we describe the flow of current in the resistors R3 and R4. So let's start by calculating the total resistance. So let me redraw the circuit. The circuit looks like this. So we have the circuit. So the circuit looks like this. So we have two resistors here. This is R1. Then we have another one R2. And here we have R3. And we have another resistor there, R4. So that is the circuit that we have, and we are told to determine the total resistance. So to determine the total resistance, you have to know how the resistors have been connected. Is it in parallel or is it in series? As you can see, here we have two connections combined together. We have, this is a series connection where the resistors are connected in end-to-end format, and we have two resistors R3 and R4 in parallel, which are connected across the voltage supply. So these two are in parallel and these two are in series. So you have to determine each of the resistors, the ones in series, and you combine with the ones in parallel. So let's start. We are told R1 is 10, R2 is 60, R2 is 60, R3 50, R4 40. So R3 is 50 and R4 is 40. So in this case, let's start with the resistors in parallel. Resistors in parallel, we have R3 and R4. Parallel connection. In parallel connection, total resistance 1 over RT is given by 1 over R1 plus 1 over R2, like that up to the last resistor Rn. So in this case we have only R3 and R4, whereby our 1 over RT will be given by 1 over R3 is 50 plus 1 over R4 is 40. When you add these two, you'll get 9 over 200. So to get RT, you take the reciprocal of 1 over RT, which will be equals to 200 over 9. When you divide this, you'll get 22.22 ohms, which is in 2 decimal places. Now, after calculating the parallel connection, let's draw the new circuit. Let's draw the new circuit. The new circuit now that we have, it looks like this. We have the voltage supply. We have the resistor R1, the resistor R2, And we have a third resistor, which is the combination of the two in parallel, which is let's just indicate the resistance, which is 22.22. So now we have three resistors in series. After computing the parallel connection, we have two resistors in series. So in series, we add the individual resistances. R1 was 10. So the RT, which is the resistance in total, will be R1 plus R2 plus 22.22. R1 is 10, R2 is 60, and the other one is 22.22. When you add these three, you'll get 92.22 ohms. So that is the total resistance RT of the circuit. So you have to know the connections that are involved in the circuit, then you compute step by step up to the end. And it is good in every step after calculation you come up with a new circuit so that you can proceed appropriately. So the other question is asking us to describe the current flow in R3 and R4. And in these two, R3 and R4 both receive equal amount of voltage from equal amount of voltage, that is. So when you look at this circuit, R3 and R4, they are in parallel, and one important thing in parallel connection, each component or in each resistor will receive a voltage equal to the voltage supply source. So if voltage supply source is 40 volts, R3 will have 40 volts and R4 will have 40 volts. That is why we are saying they will receive equal amount of voltage, and from the formula I is equals V over R, we say that current in R3 and R4 in total, they give the total current in the circuit. Why? Because in this circuit, the current that will be generated here, the same current will pass through R1, is the same current that will pass through R2, but when it reaches this junction, one of it, the part of it will flow through R3 and part of it will go for R4. Let's call it I3, I4 respectively. So there will be a current division, and from Ohm's law, then R3, because of the difference in resistances, R3 cannot receive the same equal voltage as R4, same current as R4. So the current will be different depending on the amount of resistance that is offered by each of the resistors. So we can say R3 receive less current than R4 because of the difference in resistances. So that is how you could have approached that question.